Okay, so today we got a medium problem. Validate binary tree nodes. You have n binary tree nodes number 0 to n minus 1, where I has two children. Left child return true if and only if all the given nodes form exactly one valid binary tree. What? So I got left child and right child, so they form one valid binary tree. Okay, if all the given node, so if node I has, so return nodes, what am I returning? So I just want to check if it's a binary tree. So I just want to check if I'm not visiting a node that I already visited. So what I want to do is have a, I guess 0 is the root, or is 0 not the root? Not sure. So let's count in degrees. So in degrees, in degree is equal to 0 times n, and now we go for I range n. If left child I doesn't equal minus 1 in degree, left child I is equal to I. If right child I doesn't equal minus 1 in degree, right child I plus equals 1. So now we got the in degrees, and ideally what we want that there is one node with in degree 0 and all the other nodes with is that true? Because if there is a cycle, we want at most one node with 1 in degree, and okay, so if we have if it has 0 children, no, and let's make it like this, and then for I in range n, and if index I over 1 return false, some index e plus equals 1, if tsund 0, so now return tsund 0 is, well, if I have one node, then how long is left child, right child is equal to n, and it's equal to that. So if I have one node, I don't want to have a cycle, so I want to have one node with 0 in degree, so count is equal to 1 and n minus 2, maybe. Okay, it's wrong for the first case. Output is false and expect is true. Well, number of nodes with in degree, wait, print index count 0, 1, 1, 1, or n minus 1, like this. Okay, now it passes. Maybe this is correct. It's not. So they say this is a valid. So first this goes to 0 and this goes to 1. Okay, and it also has to be connected with no cycles. Okay, so if this does not hold, okay, return false. And you want to build a graph, so the JSON C list for in range n adjacency I, append right child I, adjacency I, append left child. Okay. So after we have done that, we have a graph and we know which vertex had the we need to know which vertex vertex -1 if index I0 the vertex is I, and from that vertex we're gonna do a DFS. So let's have a visit it 0 times n DFS from vertex and def DFS v this vertex 1 for u in adjacency of v. Now if visited u, return false, DFS u, return true, return DFS. That doesn't work because I'm still not setting the visited. Visited is 1 like this, boom, okay, and like this. Okay, that still doesn't pass, that sucks. I mean, it clearly has and sum of visited is equal to n. This should pass. Okay, so some stupid problem. Simple DFS. Check if the graph has I mean, technically this would be enough. I think you just go from okay, check if the graph has degrees, has one vertex with degree with in degree 0 and all the other vertices have in degrees 1. They have only one parent. If that is not true, the graph is not a binary tree. If it is true, it can still have cycles, so just run a DFS cycles. If it is, check for cycles. If no cycle found, it is a valid binary tree. To check for the cycle, check for cycles, and if it is a single component, to check for the cycle and number of components at the same time, to check for the cycle and the number of components at the same time, run something. A DFS marking visited vertices, and after the DFS finishes and did not find a visited neighbor, check the count of visited vertices time complexity O of n, since BFS has a time complexity of O of n plus m, where m is the number of edges of the graph, but this graph has O of n edges. O of n since the graph has, since we use a bunch of auxiliary arrays of size On, and since we use a bunch of, and we store the members of each node, of which there are ON total. Post. I again did not have time for hard problem. I had to skip like 5 problems. I have too much things to do. Goodbye.